You know how sometimes you're making a list and then you accidentally realize you should have put something earlier on the list, and then instead of changing the numbers, you just add some new ones before it? That's basically what happened with the laws of thermodynamics. They're like, oh, we got these three sweet laws. Oh, crap. We need to write down a really obvious one. Well, that's what this one was, the 0th law of thermodynamics. But let's talk about thermal contact and thermal equilibrium. What is thermal contact? It just basically means that two objects at different temperatures interact. This can be through any way of heat transferring, but most often it's going to be through conduction, them touching each other. So what would thermal equilibrium be? That's going to be when two objects which were at different temperatures stop exchanging energy. Basically, what's going to happen is one object, which is warmer, has more energy. The colder object has less. They'll just keep exchanging energy until they're at the exact same temperature. So that would be when you're in thermal equilibrium. Let's get explicit now about the 0th law. We're going to define it. Let me move that over so you can see it. The 0th law of thermodynamics. We'll just call it thermo. And this one is going to seem ultra obvious. Back in the day, people used to be able to make scientific equations and like name them after themselves on really obvious stuff. But here it goes. All right, if A is in thermal equilibrium with B, and B is in thermal equilibrium with C, then, it's like I'm writing code here, then A and C are in thermal equilibrium. L-I-B. There we go. It seems obvious if I've got an object here, A, got an object here, B. If they're in equilibrium and B is in equilibrium with C, that means A and C are also in equilibrium, meaning they're all the same temperature. Seems obvious because if one had heat flowing, it would continue to flow to the other and it'd throw those off balance. So basically, as long as you have infinitely many objects that are all in thermal equilibrium with each other, even if they aren't touching, then each one is in equilibrium with every other object. Cool beans. Let's do a little bit of a review right now on heat versus temperature before we move on. So I'm going to give you guys a list from A through H, and you need to tell me whether it is heat or temperature. Some of these, it's on the borderline, so if you don't get the exact same answer as me, that's okay. But you just have to be able to justify your answer. So I'll write them out, and while I do it, I want you guys to tell me whether or not it's going to be in heat or temperature. So this is a form of energy. B, this is a measure of energy. C, can be transferred between objects. D, it depends on the velocity of particles. E is a measure of molecular or we'll just say particle motion. Be a little more general. F, it depends on the mass of the particles. G, units are joules, and H, units are degrees Celsius, degrees Fahrenheit, and Kelvin. So with those, take a second, think about them, put them into the categories you think they are. I'll be back in a second to talk through them and make sure you understand. Okay, so I put my answers up there. Some of them are to be debated, like is a measure of energy. Both of them kind of measure energy in some way. This is average kinetic energy. This is the total energy internal to a system, so I'd say that's true. Form of energy, temperature is not energy. It's a measure of average kinetic energy, so that's only for heat. C, you can't transfer temperature between objects. You can transfer heat until your temperatures are the same. Depends on the velocity of particles. Both of them definitely do. Is a measure of particle motion. You could maybe put it in heat, but I think it's more specifically talking about average kinetic energy. Whereas this one, it more has to do with, well, if you had it in there, I wouldn't be upset. As you can see, this is why people get confused about the difference between heat and temperature. There is some overlap. Depends on the mass of the particles. Both of them are going to have that because kinetic energy is affected by it, and heat, obviously, it's going to be determined by what particles make it up. Units are joules, definitely going to be heat. Units are degrees Celsius, Fahrenheit, and Kelvin, definitely going to be temperature. Cool beans.